Hi guys, welcome back to the channel. This is a video which is supposed to be short, but in fairness is not, on how to download the FPGA tools and install them, and a little bit of scratching the surface on how to start it and how to connect to the board. So yeah, you need to be patient. It's a lot to take in. I hope it's self-explanatory, and I hope you enjoy it. Okay, so how you download the FPGA tools from AMD, former Xilinx. The tool that you need is actually called Vivado. It's a very large file that you need to download and then install some version of the tool which is free. So the version of the tool which is free is limited to simple devices, to small devices. And when you are going to install, it's going to ask you which devices you want and which you don't. So please select Spartan 7 when you install, so it will be compatible with the Spartan 7 development board that we have in mind. So I'm going to link in the description I'm going to put a link here for the download page, so you land here on this page. Now, make sure you select the latest version here for Vivado, and you have multiple downloads here. The first one is actually, it's a unified installer for FPGA and adaptive SoCs. It's a Windows version, and then the second one is a Linux version. Okay, so the third one is actually a tar gzip version, and I think it contains both. I think Linux and Windows. Anyway, if you are a Linux user, first one. If you are Xilinx, is the second one. Now, sorry, I meant Linux. Now with Linux, things are a little bit more sketchy when it comes to JTAG cables, because you need to set permissions. So if you are not a good Linux user, I mean, if you're not if you don't know a lot about Linux, you might run into some difficulties, but you can search on the internet. There are solutions for all those problems. Windows is a little bit more smoother, but in terms of performance, there is a small difference between the two, so it doesn't really matter. I'm going to click here on the Windows for the download, and it's going to ask me to sign in. So I'm going to sign in, hopefully, yeah. So sign in, and it bringing here a page about me with all the data that blah blah blah, and I just hit download here. So now the download is starting. It's a very large file, so it will take a while to download. So now what you see here is actually, it's not the whole file, it's just an installer which is downloading and installing in the same time. So this is going pretty quick. For this first download, now I'm going to click on it and start the installer. Yeah. So now it's going to start downloading and installing in the same time. Now it might actually scream because I have a Vivado open here. I'm just going to close that. Okay, he's loading some Java stuff. Okay, so this is the welcome screen, right? So I'm just going to try to get as further as I can without destroying my installation, hopefully. So I'll go next here, and here is going to ask you the email address. It's the same email address that you used to sign in. So I think I have to go to this. Sure. Maybe I should put my glasses. Yeah. Right. Okay, so this is an important step here, because it's going to ask you what exactly do you want. So select Vivado. You want Vivado. Okay, and hit next. So Vivado ML standard. Standard is the no cost device limited version. So it's the cheap version, or the free version, let's say. So device limited version. So select Vivado ML standard. And now you have here a bunch of, so he already ticked some boxes because we selected the minimal. This is the minimal installation, and here you have the devices. So you have a bunch of devices here. If you're not planning to use those devices, you might untick those boxes because it will go faster. So if you just want to use the board in question, the Spartan 7, you may stick with Spartan 7. Now, if you want to use Zinc and Ultra Scale, and you can, I'm going to untick here. I'm just going to leave Spartan 7. Now, Spartan 7 or the 7 series is actually Arctic Skintex there. I'm going to leave them, the whole 7 series, let's say. Now, installation option here, install cable drivers, you need this, so leave this checked because this is for the JTAG cable, right? So let's go next here. Okay, so you need to agree with a bunch of things here. And I think there is another one or two. If you scroll down and then hit next. So now he's asking where do you want the installation directory, and what I'm going to do, I'm just going to create a slightly different directory here, so it's not going to overwrite my installation here. So I'm just going to say here new Xilinx design tools. Yeah. So it will create a shortcut to the desktop and everything. So I'm not going to hit next here because it's going to download 16 gigabytes and use 61 gigabytes of my disk. So I'm not going to do this. Now it needs this space on the disk because it's downloading and installing in the same time, but the final disk usage is going to be much less. It's only 32, and I'm kind of running out of space here. So anyway, it will create those directories for you. So ideally you should leave it, I mean, on a blank computer, on a brand new, you should leave it like this by default, exactly like he's suggesting. Now it's actually in red here because I already have that directory, so it's going to overwrite. So just leave the defaults here, and the moment you hit next, is going to start installing. I'm not going to go through that because it takes ages, but anyway, after you finish, right, let's assume that now it's downloading. It's a long process, so it's going to take, I mean, it can take more than an hour. Depends on your internet speed, right? So the moment everything is fine and is getting installed, I think this is just the last tricky step. After this is simple. So after you have this thing installed, if you go here and you type in your search box, you type Vivado, you will see Vivaldi. That's nice. You will get here the Vivado installation that you just, or here, and just click on that and it will start. Now it takes a while to start, so the moment when you click, it's not going to start instantly. It takes a while, so you need to have patience. Okay, so you get, this is the welcome screen, or the first screen that you're going to get, and you have here a bunch of example projects which are just simple projects. You can go with that, or you can open a project or create a project. Now I'll put some projects on the blog that you can do. Actually, the default test program for the board, and you can actually put that into a directory. Now there is a good practice to keep all your projects in a separate directory. I usually create a directory called Xilinx project or Fpga project, and all my projects are there. So I'm just going to open that project, which as I said, it's in a weird place called Xilinx Proj. And I'm going to open this one. It's called JTAG cable, but has nothing to do with the JTAG cable. It's just a silly name. So this is the, I could not find the JTAG. Okay, that's fine. So you're going to see something like this if everything is fine, right? So it's a project summary here. I'll try to explain a little bit those panels. What do they mean, right? So here you have a project manager panel, right? Here you have a source panel. So here you see all the files which they belong to the project. So if we go, I'll just go one by one. So you have the design sources, and it shows you here with the number how many files you have there. You have constraints files, simulation sources, you have test benches and things like that. Utilities, I have no idea what utility sources. Anyway, utility sources, I think, yeah, there are design checkpoints. So you can have checkpoints during the flow. Anyway, we are not going, this is not for how to use the tools. It's just a quick view, scratching the surface. So design sources, this is where you have your VHDL or your Verilog file. So this is the top level file. The top level is usually marked here with this kind of tiny little tree things like a hierarchical, and you can actually see the hierarchy here, and you see everything which belongs and all the the hierarchy of all the files. For example, this is the USB controller for the gamepad. This is another USB controller. This is the RGB to DVI interface, and this is the VGA interface. So this is a project which actually is testing the board. So it's exercising different things on the board. We are using this to test the board after manufacturing, and we are going to provide this as it is, and we are going to improve it as we go along. But this is already programmed on the board, so you will have this programmed in the SPI memory. So I'm going to take one of the boards here I have here. So there is a tiny little SPI memory here, and depending on the dip switches here, the board is going to start with by pulling the content from this SPI. So this is already programmed in the SPI. So if we plug the power to this, actually I'm going to plug the power to show you that I'm not kidding. I'm going to start the power supply here. Okay. So I'll try to hold it like this, and the port should be like this by default. Is coming, and it should boot from this is not the proper connector. Wait, okay, I'll take another board. Yeah, this is the latest version. So if I go like this, that's the power LED, that's the done LED, and I'm going to move this switch, and it's going to show you there some proof of life, right? So now it's a test actually running on the board, and depending on those position of the first switch, it actually tells that the LEDs are going to just go in a string, and if you move the position and you plug here a gamepad controller, it will show you the position of the gamepad controller. So it's for testing the USB interfaces. But anyway, I'm not going in detail. It's going to be a video dedicated just for that. But by default, you have this design, which is now here on the screen in Vivado. You have it preloaded on the board. So the moment you power the board, it should just, you should see activity, right? Now, when you use the board in normal operation, when you use the tools and you make your own stuff, you need to change the dip switches here, and that means that it's going to program the board via JTAG. Now, if I have here a cable, I should have one. I'm going to plug it into the JTAG port. So I'm going to plug it here into the JTAG. Okay, plugged over there. It's going to install a driver, yada yada. I'm going to put the board down, and I'm going to show you here how the JTAG is actually connecting to the board. So if you go here on the panel on the left hand side, you have a hardware manager. So if you open the hardware manager, saying no hardware target is open target, auto connect. So now it's connecting over JTAG with the board, and you should see something here. Yes, so this is the board. You see, this is the device, which is programmed right now because he just booted from the SPI, and this is the SPI memory, right? So you can program the FPGA on the fly and just see how it works, and when you are happy, you can actually program the flash memory. How do you program the FPGA? So let's program the FPGA. So I'll click on the FPGA here, XC, yeah. and I go program device, right? And it's pointing to the bit stream, which is, I think actually it's pointing in the wrong place, so I need to go by hand and point him into the right directory. I don't know, I'm not sure why it keeps pointing in some random directory, but I know where it is. This is in my project file, is under runs, under implementation, test bit. So now it's going to program the test bit, which is the result of all this project, into the FPGA. So I go and I'm going to hold the board, so you can see that the done LED is going to go off and then it's going to go on. So I hit program now. Yeah, that was all. The FPGA is programmed, but now it's actually not with the content from the SPI, it's with the content of the file, the bitstream. Now let's say that we want to program the SPI with the. Now, in order to program the SPI, you need to create the file first. I have the file created because the structure of that file it's a bit different. So you need to create that file beforehand. I'll show you how to create it, but let's see how we program it. So how we program it, I'm going to put the board down. I'll click here on the SPI memory. Click right on the mouse and I say program configuration memory device. So here is asking what to do. So that's, you see here is pointing to a file called the MCS file, the memory content S. I don't know what S is. And here is going to erase, blank check, program, verify, right? So it's going to go through a few steps, and I'm going to hit OK, and you will see a progress bar, which is basically made of 3 steps. So the first step is programming something in the FPGA so he can actually reach the SPI memory. Now he's making a blank check, and now he's actually programming the SPI. So you can program your own, let's say you program a retro computer, a Sinclair Spectrum, let's say. So next time when you start, the board will just boot as a Sinclair Spectrum. Okay, it takes a while, it's not that fast like programming the FPGA. So when you program the FPGA, you need to keep in mind that when you cut the power, it's gone. It's like, it's going to forget. So flash programming completed successfully. Nice. Now, how do I make the file? Because that's interesting. How do you prepare the file? So when you prepare the file, you need to know the type of your memory. So I'm going to take a screenshot, and you can actually pause the video and see. So how you make that file? You go tools, and I think program generate memory configuration file, right? So you select this menu. Now we are assuming you already have a bit stream. So you made your design, you went through the whole flow, and you got a bit stream. The bit stream is the file which goes in the FPGA. But based on the bit stream and the type of memory, you need to create the memory, the SPI memory image. So you go generate memory file. So this is a bit tricky here. So it's asking which format. It's MCS format. Custom memory size, I don't think it really matters. File name. So here you need to point to the bitstream file. So it's saying, okay, how would I start? So I go there and I go. No, actually, this is the target file that you are going to create. So you say let's call it something else. Let's call it new MCS, right? Now we say save. So it's going to create here a new MCS file. Interface is smap by 8. Load bitstream files. Now I need to tell, okay, what do I want to put in this file? And I say, oh, load bitstream file. And now I need to point it to the bitstream file, because you can actually create partition. You can put more than one bitstream in one SPI. But this is an easy example. We are putting just one bitstream file. Okay. Okay, and we say okay, and we hit okay. So now it has created this new file. So if you look here in the log, it's saying that 0 critical warnings, and has used this test bit and has created, hopefully has created that file. So let's see if the file is there. So let's say if I want to program, say program configuration memory. and here we search for that file. Yes, there is a, where did I put the file? I think I put a file here somewhere. I need to search for that. Runs implementation. Yes, this is new MCS. You see, this is the file that we created. So if I hit OK now, it will program my SPI with this newly created file. So, as I said, this is not for teaching you how to use the tools. This is just to show you the basic. Now, when you finish with the programming or you want to iterate again, you need to close this. So this window is going to show you what you're doing right now. So right now we are connecting over JTAG and we do all this mumbo jumbo programming, the Fpga programming, the SPI memory. When we finish with this, we go here and we disconnect the hardware manager, right? How did we get to the hardware manager? From here, from the panel. So let's say we want to run an implementation of the file. So I go here and I click on the test on the top level, and I go and I say here first I want to run the synthesis. Synthesis is the equivalent of the compilation in the software land. So I go synthesis, the first step, let's call it. Now when you hit here, it's going to ask you how many cores you want to use and so on. I hit OK. When it's actually running synthesis, you will see here some spinning wheel here, but in the same time you see here, this is actually a good place to look what is going on. So it's running synthesis here, and of course you can see here some things changing because it can run with multiple with multiple cores, multiple processors, so to speed up the whole process. So it's kind of spawning multiple processes to speed up the compilation or the synthesis. So you will see here all the runs. You see how the synthesis is actually checked here, and he said, okay, I finished synthesis. Now what do you want? I want to run the implementation. The implementation is like the second step. Now the implementation is actually made of three steps or sub steps. You see here in the top right, it's saying initializing design. Actually what it does right now is actually looking what needs to be done and if the files are there and things like that. So then it's running optimized design. Now those are fancy names, but actually what is happening behind the scene I will explain in a different video, because it's actually very logical what is happening. And then you see routing design. Routing is when it's connecting everything. So it's creating all those internal connections to the blocks that... Okay, so the implementation step has finished. And now he's asking, okay, so what do you want? Oh, I want to generate the bitstream, which is the third step. I said we have three major steps. So now he's actually creating that file, the bitstream file that you are going to program on in the FPGA, or you are going to create an SPI memory image for the SPI memory. So this takes a while. Again, you see here in the corner how long it takes and what is going on. In the same time, you see here in the middle of the screen, but you see here in the middle of the screen only if this project summary is open, because I can close this. Right? It can go away. But this one is still. And now it's saying, okay, look, it's I finished the bitstream. And now you can open the hardware manager from here. So it kind of shows you what would be the possible next step. What would be the possible next step? Now you have multiple options here. You can open the design at every checkpoint, and you can see inside the design, and we'll flesh that out. But this is like a 100 miles per hour. So open design hardware manager. It's exactly like you've seen before, where we connect to the target via JTAG auto connect, and we can program the FPGA directly or the flash memory. You see here how it's connecting, and you have this and that. Now, if you see here, if you click on the board, actually, so you have the board, and on the board you have the FPGA, and then you have the SPI memory attached to the. So it's like a logical view. Now, if you click on the board here, you can see the serial number of the board. So this is AD, is adaptive design, and 0042. This is a serial number which is programmed on the board. The same serial number you can actually see. I'm going to cut the power. When I'm going to cut the power, probably this is going to scream because it's losing connection. It didn't scream. No, when I yank the cable, probably it's going to scream. Yeah. saying closing target. Okay, closing target. So the serial number is actually programmed in a memory here, in a small I2C memory on the JTAG interface. But the same serial number is actually encoded in the QR code. I'm not sure if it's visible. Yeah, the QR code here. So you can read it with a phone. If you have a phone which can read the QR code, you can actually see the same serial number. Anyway, so this is like a 100 miles per hour. You download the tools, install the tools, make sure you select only the devices that you care about. Don't go mad, because it will take a while to install everything, and it will take a lot of space on the disk. So yeah, have fun. I'll put this video on my blog. I'm not going to heavily edit this. It's just taken one go. I hope you enjoy it and you learned something.